Hello friends, in this video today I am going to explain different types of vectors. In my previous video just I gave introduction regarding scalars and vectors. I would like to remind once again that a vector is a physical quantity which has magnitude as well as direction. That means to explain a physical phenomena, we need the help of physical quantities. The quantities may be scalars or may be vectors. To describe the quantity properly, we need many cases the magnitude as well as directions. That means we need the help of vectors. So today in this video, I am going to explain the different types of vectors. See that first one is the unit vector. Unit vector. What is this unit vector? In fact, unit vector of a vector is a unitless vector. I can say that unit vector of a vector, suppose it is a unitless vector having unit magnitude. Magnitude is unit and lying in the direction of the vector. That means I want to say that unit vector means its magnitude is 1. It only represents the direction. I mentioned that unit magnitude and lie in the direction of the vector. That means this vector magnitude is 1. That means I can say that it only represents the direction. Then how we write it? So here I can say that this vector, suppose A represents the vector. So in a vector there is a magnitude as well as direction. So the magnitude I can write in the form of mod, and direction I can write in the form of a cap. Cap or a hat used to represent the direction only. That means this is the magnitude, this is the direction. But I said that unit vector having unit magnitude, that means this is equal to 1, or I can say that a cap is equal to vector A upon modulus of vector A. That means this one I am dividing by the mod A. It is called me only the direction. So unit vector means a vector having magnitude 1. Magnitude 1. It only represents the vector. Sorry, it represents the direction only. So to express the direction, generally we use I cap, J cap, K cap. Here I cap represents the direction in x axis, J cap represents direction in y axis, and k cap represents the direction in z axis if it is the space. Generally, I cap, j cap and k cap we use to express the vector along x axis, y axis and z axis. So this is about the unit vector. Next kind of vector is non-vector. Children, I hope that you might have subscribed the channel. If you have not done, you can do it now. As a result, you can get the information in right time regarding the upcoming videos. See here. So second one is the non-vector. Non-vector means a vector with zero magnitude. A vector with zero magnitude and arbitrary direction. Magnitude is zero, but there is no specific direction. It may be any direction. So I have written it arbitrary direction. So it is represented by this way. Suppose we are going to add zero vector or null vector with a vector. The previous vector value will not change. Either we multiply or subtract. For example, suppose P is a vector. I added zero vector. That means answer is only P vector. Or Q is a vector. I subtracted zero vector. This is also vector Q. There will be no difference in the previous value if you add or subtract a vector. Now, let us see about the multiplication. Suppose there is a dot multiplication. Vector A dot null vector. The answer will be 0. But at the same time, the vector A cross product null vector, the answer will be a null vector. See here. Here the null vector multiplied with the vector A in dot product. The answer is 0. But when same thing I multiply with the help of cross product, the answer is coming the null vector. I have mentioned here the vector symbol, but here it represents only 0. This is about the null vector. Next one, equal vectors. Equal vectors. Two vectors are said to be equal if they have same magnitude as well as same direction. See here. Two vectors are said to be equal if they have same magnitude as well as same direction if they are of same physical quantity. Two vectors of same physical quantity. I can say that two vectors of same physical quantity are said to be equal if they have same magnitude as well as same direction. Suppose this is the vector A, this is the vector B. Vector A, vector, this line represents vector B. Already in my first video I explained about the magnitude and direction. The length of the lines represents the magnitude and the arrow mark here represents the direction. Length represents magnitude means, for example, 3 centimeter or 100 kilometer. It does not mean that I shall draw into 100 kilometer. Not like that. I may take 1 centimeter as 100 kilometer, 1 centimeter as 10 meters. It represents. So the length of the vector represents the magnitude, whereas the arrow represents its direction. So two vectors are equal if they have same magnitude as well as same direction. So next one is the negative vectors. Negative vectors. So this is the fourth one. Two vectors of equal magnitude, two vectors of same physical quantity, equal magnitude are said to be negative if their directions are opposite. See here. Two vectors of same physical quantity are said to be negative if they have same magnitude but opposite direction. That means this is vector A, this is vector B. Their magnitude same, but the direction is opposite. They may have same line of action or they may have different line of action. For example, you see that they have same line of action, does not matter, but their directions are opposite. Their magnitude is same, but their directions are opposite. So we can say that they are, this B is the negative vector of A or A is the negative vector of B. That means I can say that suppose F1 is vector, F2 is a vector, their magnitude is same but the direction is different. That means I can say that F1 cap is equal to minus F2 cap. Like this way I can represent. So fifth point, parallel vectors. Parallel vectors. Two vectors are said to be parallel. Two vectors are said to be parallel. Two vectors are said to be parallel. Without, I can say that, without common line of action. If they have same direction, that means the angle between them, see that this is vector A, this is vector B, vector A, vector B, both are parallel. Their magnitude may be same, may not be same. I can say that the angle between A and B vector is 0. Only direction is same, like this. F1 cap is equal to F2 cap. This is said to be parallel vectors. Next one, anti-parallel vectors. Number 6, anti-parallel vectors. Two vectors are said to be anti-parallel if their directions are opposite. So anti-parallel means two vectors are said to be anti-parallel, means without common line of action. Two vectors are said to be anti-parallel if they are in opposite direction. This is anti-parallel. They are in opposite direction. So, this is about the parallel and anti-parallel vectors. Next one I am going to say about coplanar vectors. Coplanar vectors means number of vectors lying on the same plane. Coplanar vectors. What is coplanar vectors? See that. Suppose this is the x, this is y. Here is a vector, here is a vector, here is a vector, here is a vector. Number of vectors are there. So I can say that number of vectors lying in one plane You can see that here this is the plane of the whiteboard. All are present in one plane. So those are present in one plane. We say they are coplanar vectors. Next one. Seventh one. Concurrent vectors. Seventh one. Concurrent vectors. What is concurrent vector? Number of vectors either actually meet or appear to meet. A number of vectors either actually meet or appear to meet are said to be concurrent vectors. For example, you see that this is concurrent. Appear to meet. This is concurrent. If they have a common initial point, they are said to be co-initial vectors. So, co-initial means this is co-initial means common initial point. This one we can say coterminus means common terminal, but all are concurrent vectors. So concurrent vector, it may be common terminal, it may be common initial point. If it is the common initial point, we say it is co-initial. If it is the common terminal point, we say common terminus. This is co-initial, this is coterminus. Okay, so this is about the concurrent vectors. Next, I can say one localized vector. See here, localized vector. What is localized vector? A vector with fixed initial point. Its initial point is fixed. You see that x-axis, this is y-axis, this is a OP. OP is a position vector. So, for example, position vector. Its initial point is the origin, or you can say reference. It is fixed. So, I can say it is a localized vector. Similarly, okay, this is the 9th one. 10th one is the non-localized. non-localized vectors. That means vector without any fixed initial point. So children, today in this video I explained the different types of vectors. So in my upcoming video I shall explain the remaining part of the topic. It may be multiplication of a vector with a vector. What are the different types of multiplication? In my next video I shall explain. Until then, bye.